What's up, guys? This video is going to be about the freezing point lab. And so what I'm going to do is I have 3 different test tubes here. This one contains water. And what I'm going to do is measure the freezing point of just plain water. I'm going to do that by putting it into this ice bath and measuring the temperature with this thermometer. And we'll just keep on waiting until it freezes. We'll record the temperature every 30 seconds until it freezes. And we're also going to do it with these 2 solutions. So these are water that have a little bit of ethylene glycol dissolved in it. This one right here has 10% ethylene glycol, so 10% ethylene glycol, and the other 90% is water. And then this one is 20% ethylene glycol solution, so a little more concentrated solution. And so we're going to measure the freezing point of each one of those, the temperature at which they turn to a solid. This is some rock salt, and it's like used for making ice cream in one of those old-fashioned ice cream makers. And so the setup here is going to be a lot like one of those old-fashioned ice cream makers. This is just an insulated container, just like a plastic cup, and I have a bunch of ice in it. And I've added some of this rock salt to the ice. And as that salt melts the ice, it's going to make it extra cold. And so this will actually be like -10 or 12 degrees Celsius. It's going to get much colder than if it was just plain ice without the salt. So this is my ice bath, and I'm going to be taking each one of the test tubes and putting it into the ice bath like that. And then we'll take our thermometer, put it in like that, and we will stir it and monitor the temperature. All right, so let's get started. You guys are going to record the temperature every 30 seconds. So you'll need to start a stopwatch when I put this in, and then record the temperature every 30 seconds until it freezes. After it freezes, you should probably do another 30 seconds or minute of recording the temperature as well to see what happens after it's become ice. All right, so let's get started. We'll put this into our ice bath, and we will start stirring. So I'm going to be stirring this, and then you just need to, every 30 seconds, you can pause the video if you need to, and then record what the temperature is. You're going to be making a graph. So the graph is going to have time on your x-axis along the horizontal axis, and then your vertical axis, your y-axis, is going to be the temperature. And so you'll see the temperature coming down as time goes on, and then you're going to mark where it freezes as well. Stir this a little bit. All right, so we see the temperature still dropping, and you should be recording the temperature. I'll try to hold it right side up there. You're going to be recording the temperature every 30 seconds until it freezes. And we need to make sure that we stir it. If we don't stir it, it can do something called supercooling. It might do that a little bit anyways, but supercooling is when it actually gets colder than the freezing point. Still liquid, it hasn't frozen yet. Okay, so we're actually below 0 degrees. I'm going to make sure I keep stirring because I know I'm close to the freezing point. And you actually see something interesting happening right there, right? So it dropped below freezing, and then it came back up to the freezing point. So it actually was super cooled a little bit. It was a little bit below the freezing point, and then since I kept stirring it, it is now at the freezing point and starting to freeze. And you guys will see that on your graph. It'll actually drop a little bit lower than what's expected, and then as it's freezing, the temperature remains constant. So you can see the temperature is remaining constant. And then as soon as this turns to a solid, you'll see the temperature start dropping again. Let's see if we can pull this out. It should be freezing right about now. Yeah, and ice is starting to form. And then once it completely freezes, we should see the temperature start dropping again. As it's freezing, the temperature doesn't change. It stays right at the freezing point as it's freezing. And then once it's all frozen, then we should see the temperature come down again. All right, seems pretty good. All right, so let's now do the 10% ethylene glycol solution. So we're gonna do the same thing. You guys will have another row in your chart, and you will record the temperature every 30 seconds until this one freezes. It'll probably have the same kind of pattern where it, let's see, there we go. All right, so we've got the ethylene glycol 10% solution into our ice bath. And so same thing, just record the temperature every 30 seconds until it freezes. You'll probably see the same thing. The temperature will probably go down, and then eventually it'll actually come back up and flatten out, and that point where it's flattening out is where it's actually freezing. This one's cooling faster. I think it's just because I have a little better contact. I have the test tube a little bit deeper in the ice bath, and my ice bath may have gotten a little colder as it's sat here a little bit longer. So we see it's cooling pretty quickly. We're to 0 degrees. That's when our water froze. Now we're negative. And we should see the temperature keep dropping. And then at some point, the temperature should actually come back up. And when it starts to come back up and then flatten, that's when it's actually freezing. I'm going to make sure I keep stirring it. All right, and you can see the temperature actually coming back up and leveling off. And now it's stopping, it looks like right at -4 degrees Celsius. And so this is when it is freezing. It dropped below -4, and then it came back up, and as it was at -4, that's when it was starting to freeze. And you can look at that, it's frozen. All right, and then last one, we're gonna repeat the same thing, this time with the 20% ethylene glycol solution. Get that down in my ice bath. And then same thing, record the temperature every 30 seconds. We'll see it get down to a very low temperature, and then it'll probably pop back up as it's freezing. This one has more ethylene glycol in it, and it looks like we're getting to a lower temperature before this one starts to freeze. Still a liquid. All right, we're at negative 10 degrees Celsius. Gotta make sure we keep stirring. It's gonna change pretty soon, I would guess. And there we see the temperature coming back up. And when the temperature comes up and then kind of stabilizes, then this is when it is starting to freeze. There it is, frozen. All right, so I think that is all the data that you need. You just need to make a graph that shows time along your x-axis and temperature along your y-axis. You're going to have 3 different lines, one for the water, one for the 10% solution, one for the 20% solution. And we saw that they each froze at a different temperature. They each had a different freezing point. And then you'll answer some questions about why they may have had different freezing points.